started. Okay, guys, we are ready for today's session. So okay, today what we are learning is about, the security in Postgres. Okay. So security in Postgres, this is this lesson, plus we will see so how to run multiple instances of Postgres in one server. Okay. And we will also see some maintenance tasks. So that is what today's session is about. So we will see how it goes. And before we go to the today's session, I would like to ask how the lab exercise went for the Thursday session. So the databases.txt I asked you guys to work on. So how it went. So everybody is able to complete that. So everybody got able to complete the lab exercise, which is given on Thursday. Anybody has any issues, not able to complete? So you can tell me now itself so that, we can have a look into that, or you can ask me. So for any help you need, so during today's session. So, but make sure, all the lab exercises are done. Okay. So in today's lesson, we are going to do about, learn about the security. So object level security, we have learned we can grant and revoke the permissions like select, insert, delete. These are the privileges we can grant, and we can, what we say means revoke from the objects. So that is object level security. Okay, that is the lowest level of security, object level security. On top of the object, so we have a database level security. So the database level security is controlled by user and password. So we have the user and we have the password, and we have to submit a username and password, correct password for that user. That is one of the thing. So the database level security. The second thing in the database level security is connect privilege. So we learned a great deal about the connect privilege in our last session, right? So what is the connect privilege, and to which object we give that? Anybody?
Read
Which object we assign the connect privilege?
to the user.
you
The
gave select
connect privilege,
permission, right?
connect privilege. Okay. So
CTC.
we assign to a user on which object?
Tables
On a database, right?
on the database. Correct.
If a user wants to connect to Postgres instance, the user requires connect privilege on at least one database. So without having connect privilege on any database, so the user is not going to be not able to connect. That is that is restricted. So one level of security after username and password, you can also control the connection by controlling the connect privilege. By controlling the connect privilege. If the user does not have connect privilege on the requested database which the user want to connect, the user will not be able to connect. Or the user does not have connect privilege on any database in the instance, then the user will not be able to connect to the Postgres instance. So connect privilege on one of the databases must for a user to be able to connect. After getting connected, the user requires usage privilege on one of the schema within the database the user has connected. If the user has connected to employees database, so in employees database, one of the schema should have usage privilege for that particular user. So, within the database, we have three levels of connection until three levels of what we say controls until the user comes to the level of table. So until the user comes to the level of table, we have username and password check. So we have connect privilege check and we have usage privilege check on the schema where the table is. Just having privilege on is table does not give access to the table. You also need the usage permission on the schema in which the table is, and you also need a connect privilege to the database. So in which that schema dot table is, and you need a username and password. So this is the second level of security. The first level is, object level like table level security or stored procedure level security, view level security, where you are having execute privilege or select, insert, update. So these privileges. So on top of that, to reach that object, so the user requires usage privilege on schema, connect privilege on the database, and also the user should have a proper username and password. So that is the second level of security. And the third level of security is object level security. Above all, there is a first level of security, that is application and server level security. So that is the first level before user is validated. Okay, before the connect privilege on the database is validated, so server and application level security comes into picture. So that is the first level of security. When the user tries to connect to the Postgres, so the very first thing the user encounters is, server and application level security. And this is unique in Postgres. So this is unique in Postgres. Okay. So in this lesson, we will be learning how to implement that server and application level security. Already we have learned the second level. So database level security we have learned. So database level security we have learned. uh, that is connect privilege, how to create users and assign passwords we have learned, schema permissions we have learned. So second level security we have learned in the last session. And the third level security also we have learned how to assign privileges. Now, in this class, we are learning a first level security which is validated above anything else. Above anything else. So the very first time the user tries to connect, so or every time the user tries to connect to the Postgres, so before username and password is validated, the server and application level, this security level comes into picture. And this is where the IP address of the client is checked. Okay. IP address of the client is checked, and this is implemented by a configuration file called as hba.conf file. This is the file from which we implement the first level security. So if you go to your labs data directory, so that is the cluster data directory, you will find this file hba.com. Okay, exit from here. Okay, I'm live in where live. So I will go to the 14 data. Okay, one among these file is, hba.conf file. So the very first level security is implemented through this file. And, a DBA has to manually edit this file in a text editor like VI or Nano. So there is no command with which you can, make entries or edit entries from this file. So this file is managed completely outside Postgres. So the reason why it is managed completely outside Postgres is even somebody is able to, hack the super user password or something, but still they will not be able to touch these rules, the first level security rules. So that's the reason even in the 15th version, which is the latest version, so there is no way you can edit the entries of this file or add or remove the entries from this file from any Postgres command. So you cannot touch this file from Postgres. So you have to edit it from the operating system. If it is a Windows Postgres server running on Windows server, you need to open this file in Notepad and edit. If it is Linux, so then you have to use Nano editor or VI editor. If you are comfortable with VI editor, use VI editor or Nano editor. So which is a bit, easy to use. So you have this, any editor you use, not just VI or Nano or Notepad, any editor you use. So you have to modify this file only using the editors. Okay, only using the editors. So you don't have any other option. So the pghba.conf file is the file from where, so this particular first level security rules are written. So in this lesson now, what we focus is how to write these rules in the file. So in this file, how to write these rules. So that is what we are focusing on. Let me open the file and show you. So a lot of comments are there. Lot of documentation about how to write the rules. Okay. So now some rules are written here. So some rules are written here. Okay. So until here, this file is like, all, some kind of, documentation or, some kind of instruction for the user or the DBA how to use this file. Okay. First, let me take a backup of this file. So then what I will do is I will remove all the junk from this file. So how I am going to take a backup is I will just make a copy of the file. So I'm saving it in the home directory of the user in Linux operating system. So this tilde, this tilde always represent the home directory. Okay. It's like the home button. Okay. Got. So I made a copy of this file in the home directory. Now I am free to open this file and edit this file. So before editing this file, always make a copy of this file just in case. So if you mess this file, the connections will not work. The Postgres will run, but the connections, the users will not be able to connect. Okay. So, that's the reason always, make a copy of this file before messing with it or before changing it. So let me open this file and show you. All these are comments. You can read and you will know how to write this file. Okay. So these are the actual rules which are written till up till here. So we have only the comments. Okay. So what I'm going to do now is, I'm going to delete all these comments. So, all the comments I am going to delete. So I just want my rules in this file. I don't want anything else in the file. Okay. So I only want, okay, always make sure that you have only rules because so all these comments will distract you from the, what we say, reading the rules carefully. Okay. So that's the reason, you remove all the comments, make this file. So only to what rules we are written. Okay. So what I'm going to do, I am going to delete all the lines from, the first line up till here. All the lines got deleted. Okay, I'm going to leave this comment line because it is giving us heading. Okay. So here are the rules we have. 6 rules are there totally. So these 6 rules are there by default. These are the rules by default which are generated and they are very generic. They are very generic. Okay. So every line has a rule. Every line here is a rule. Every line is a rule. And every line has, 5 columns. You can see the first column type, the second column database, the third column user, the fourth column address, and the fifth column is method. Method is authentication method. Which authentication method to use? Postgres supports quite a few authentication methods. Okay. And how the matching is done, is just by these 4 columns. When an incoming request comes, so what happens is, it will go to the first line first. So whether the incoming connection request is matching to the first line, so it will check these 4 things. So, we have the type that is local. That means, local means local host. So that is a local connection. So if it is a local connection, connecting to any database. All means any database, all databases. So connecting to the user, requesting user is any user. So then, you have to go with peer authentication. Okay, I will come to you what is meant by peer authentication. In the same way, we have the host. Host means TCP connection. Okay, local means unique socket connection. So host means TCP connection. So it could be the local, it could be the remote. So, generally a TCP connection is called as host connection. Okay. Okay, the type of connection is TCP. Database is again no restrictions. All database, any user. If it is connecting from the loopback IP address locally, it is a TCP connection, but that user is connecting locally. So admit that user by checking the password. Okay, here for non-TCP connection, the first line local says so that so if the user is connecting with unique socket to any database, so it could be any user, so connecting through unique socket, so apply the peer authentication method. Here, any user connecting to any database doing a TCP connection, so apply the username and password method, so as the password. So what is peer method? So I will explain you what is the peer method, and other methods also I will explain you. Okay. 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 So here we have, so let me just attach my writing pad. Okay. So, that file has, the columns like 5 columns. The first column is type. So the first column is type. So the type column indicates connection type. And the connection types include the unique socket. So that is called as local. So unique socket. Host. So that is nothing but TCP. Host SSL. TCP IP with SSL. Okay. Host SSL. and we have host no SSL. So if you have any client or any user who cannot do SSL, you can write a rule for that one also. TCP IP without SSL. Secure socket layer. I think you know the TLS connections we have. So today we are calling them as TLS connections. Okay. So these are the what we have means connection types we have. Local host, host SSL, and host no SSL. So local means the unique socket connection. So in the last or previous class I have explained. So what is a unique socket connection? What is a TCP connection? So these are the types. Apart from type, you also have so connection type, and what we have is a database. So when a connection is made, the user will always connect to a database. User cannot connect without mentioning the database name. Always user has to tell so which database it is going to connect. Okay. So always there is a target database. Without a target database, you cannot connect to Postgres. So like, in SQL Server, you may have a lot of databases, but we can connect without targeting to any particular database. So that is possible. But here, when you are making a connection, you have to specifically give which database you want to connect to. So that is, the database. User trying to connect. User. So the user itself. Which user? And you have the address. So here address means IP address or host name of client. So IP address and host name of client, from which machine the connection is coming. So what is the source of this connection, or the client's IP address and host or host name. So you can give the IP address and host name here. And the last column is method. So I will write this column with a different color. So method is authentication method. So method is authentication method. So which authentication method to use? So Postgres, supports quite a few authentication methods. We will see. So them we will have a. So we will see what authentication methods Postgres supports. So these are the 5 columns you need to put into that 5. Okay. So now the theory apart. So let us concentrate on the practical part of it. So let us concentrate on practical part of it. Just a moment. Okay, guys. Sorry for that. That is a bit of important call. So, so I was explaining these are the five columns we have to mention. So, the theory part. So let us how to translate it to practical. So that's what, we will see now. So what is practical part of it? So, so I am connecting to Postgres. Okay. Here I check all the users I got. I got 4 users. So in that, I have Aaron, Sami, and Scott. Normal users and Postgres super user. That's great. I will check databases. Select name. Okay, so we have what we say means 4 databases. We have Postgres, MyDB, and you forget about the Postgres. So template 1, template 0, you forget about these databases. So, So for example, I want to write a rule like this. So, we have the Aaron user, we have what we say means, so we have Aaron user, so we have our Sami user and Scott user. I just want to start by writing some rules for these guys. Okay. So I want to start by writing some rules for these guys. So, so let's see how I can write the rules. Okay. So rules can be written. So rules can be written like this. So I will explain what I want. So what I want is user Scott should be able to connect to MyDB database. The user Scott should be able to connect to MyDB database only. So no other database. Okay, Scott should not be able to connect Postgres, or user Scott should not be able to connect to, you know, template databases we have. Okay, so should be able to connect MyDB from, okay, any client. So from any client, so any client machine. Okay, with the so with the so cram uh, with Scramshaw authentication method. So this is what we want. The user Scott should be able to connect to so the database MyDB only, no other databases. We want to restrict the user Scott so from connecting to other databases. So number 2 is another rule I want for user Postgres. Okay, so the user Postgres, okay, should be able to make TCP or TCP or unique socket. User Postgres should be able to make TCP or unique socket connection, okay, to any database, okay, any database, okay, but locally, locally, okay, with the password authentication. So this is how you might have your requirements. So this user should be able to connect to this database, and this user should be able to connect to this database. So you have your requirements like this. Now, how to translate these requirements to the rule? So to the rule. So that is what we will see now. So, the user's card should be able to connect. We already know that TCP. So we have two types of connections here. So four types of connections here. Local, that is unique socket. Host, that is TCP IP. Host SSL means so secure connection. Host no SSL means forced no SSL connection. Even if the client wants the SSL connection, the server says, no, you cannot do SSL. You have to do only, so no SSL. Generally, if the client is willing to do SSL, Postgres allows the clients to do SSL connection. So after this topic, we will also come to the SSL topic also. So the client will do, so the client is allowed to do SSL connection. Okay. The thing here is, so that is what the connection type determines. So you have the four options here: either go with local host, host SSL, or host no SSL. Database is database name MyDB, Postgres template 1, template 0. That is the upfront database, employees database. You need any other database you have. User, which user? Scott, Sami, Aaron. Postgres also. Even the Postgres super user also needs a entry in this. The Postgres user is not above the HBA.conf file rules. Okay, so if it does not have the HBA.conf file rules, your Postgres user will not be able to connect. So even though it is the super user, so this file is above all. So like, you will have the first level of, the airport security, like the CISF security, this is like that. So you may have a ticket, you may have everything, but you have to still pass through that security. Okay. So that is what, the HBA.conf file is about. Okay. Address, you can also tell this user can connect only from this client, not from other clients. So this is very helpful. Authentication method. So we will come, okay, regarding the address and authentication method, I will give more elaborate understanding. So first of all, let us see about, the address. So what is this address is? So address column. So what happens is, mostly in many of the today's application, okay, in many of the today's application, what happens is, so you will have the set up something very similar to what I'm showing you. Okay. So something very similar to what I'm showing you, you have this. Okay. End users. Okay. So you have DBS. developers. So we have developers. So DBS. So Postgres server. So we have application server. Okay. So now the thing is, the end users, generally the end users don't connect to the Postgres. So the end users always connects to, the application, right? The end users always connects to the application. They don't connect to the database. Okay. So, the application connects to the Postgres server. Okay. And uses, so PG connection. So with with a user. So here, the PG user. So application uses one user to connect to the Postgres database. And then the DBAs and the developers also connects to the Postgres database directly. Only DBAs and developers connect to Postgres directly. The end users does not connect to the Postgres directly nowadays, or any other. In fact, any other database, it is like this. So, any other database, because, the application architecture is like this nowadays, right? So end user connect to the application server, then application server makes a connection to the database. All right. So here, you have the application server's IP address. Let us say this is 192.168. So 192.168 dot, so let us say 1.2. So this is the IP address of, the application server. So this user, the app user which you are using, so always connects from this IP address, right? So it won't connect from any other IP address. Okay. So it won't connect from any IP address. You can restrict the app user to this IP address. So you can say this app user. So let us say I'm using a user called as app user, app underscore user. This is the user application is using to connect to Postgres database. So the app user always connects from this IP address, no other IP address. I can restrict the app user. So it enhances the security, right? Nobody can hack the Postgres server with the app user from other machine. So because the app user only connects to the from the application this IP address, or you can also use the host name there. So that is how you can what we say means, so you can give the addresses to restrict the access to limited number of clients for user. So another thing is what we need to learn here about is the authentication methods. What authentication methods are supported by Postgres? So there are quite a few authentication methods. Number one is password. Number two is MD5. Number three is Scramshaw. Number four is trust. Trust means don't ask password. Trust this user, don't ask password. So that is trust. So Postgres will not prompt for password. Number five is reject. Reject means just reject the connection. So drop the connection. Okay. So you can also make that if so and so combination of connection request with so and so username database and address combination is coming. So just reject that connection. We don't want that. So, you can also give reject rules, but be careful with the reject rules. So be careful with all the rules. If you mess up the rules, the users will not be able to connect. Okay. So that is number 5, reject. So number 6 is peer. Number 7 is ident. So this is passwordless, and this also passwordless. Okay. So these are also passwordless. Okay, peer and ident also passwordless. Trust is passwordless. No password is required if you say trust. Okay. Peer and ident also, they don't ask password, but these are all prompt for the password right now. So when we are able to connect, we are connecting. So it is prompting for the password. So password MD5 scram shop. So these are all okay. So ask for password. Okay, trust, peer, ident. So these three does not ask for password. Reject means it will just reject the it won't come till password point also, because the connection is dropped. Okay. Apart from these 7, we also have some others. So apart from these 7, we also have some other types. So these are GSS, SPI, KRB5, GSS, SPI, KRB5. 11 is, there are few more. So PAM, LDAP, radius. Okay. So these are the what we say means uh, authentications methods we have. So GSS, SPI for Windows authentication. Windows authentication is not built into. You need to install additional third-party software. Actually, in the enterprise version from EDB, so you will have that Windows integration, but here not. So Kerberos, PAM, LDAP, all these requires, so LDAP is LDAP. So all these requires third-party tools. So these authentication methods are external. So, so these are all external authentication methods. So they require the libraries to connect to the respective LDAP server, or, Kerberos or PAM. So they require additional libraries, so which are not included. So whereas up till until the ident, that first seven, they are all included in community version. So this KRB5 means, Kerberos authentication. So unique spam authentication. So that is PAM, LDAP, and radius. So LDAP is LDAP server. Radius is like LDAP server. We also have a central authentication server called as LDAP. So for Active Directory, you have to make an entry as GSS or SPI. So that is Active Directory for Active Directory. So these are all external authentication methods. Remember, so Postgres user goes to the external authentication server only to validate the password. So it won't go there to validate the user privileges. So even if you are using an LDAP user or Active Directory user, that user still needs to be created in Postgres. So you need to create that user in Postgres, and you need to what we say assign privileges. So all the privileges details are maintained in Postgres. Okay. Only for password authentication, the user will go to the authentication server, and so once the authentication is successful, so it will come back, and then the privileges of that user are taken, okay, from the local tables. So the user must exist in Postgres, even if it is an Active Directory user or LDAP user, that must also be created in Postgres as well. And any grants you are doing, so you have to do in Postgres only. It will go to the LDAP or Active Directory only to what we say means password verification. Okay. So that is about external authentications we have, and internal are password, MD5, scram SHA. These are, so all these three requires password. All these three requires password. Okay. So so the only difference is right now this is the default. So right now it is the default scram SHA, and you should use this one. Those are older methods. So MD5 passwords were used in older versions like 11 to, so I think not even to 11, 10, those versions have MD5. Older encryption. So don't use that, it is not recommended. Okay. It is there, still it is there for backward compatibility. So still it is there for backward compatibility. Okay. So it's still it is there for backward compatibility. This password is, on other hand, this password is plain text password. So from the client, the password is sent in plain text. So for some application, it is needed. So some applications cannot send encrypted passwords. For example, your Postgres server, so is using Korean language or Japanese language, and generally in such case, it has to send the password in plain text. So for some specific, situations, so plain text password transfer is needed between client and server. So that's the reason we have that option. Okay. So MD5 is older option. So right now it is not in use. Scramshot 256 is the latest one, and we should use that one. So all three requires the password for the user. They force the user to give the password. Okay, trust does not ask any password. So, you can just log in. The user can log in without entering the password. That is trust. Reject is, reject the connection if this combination comes, and peer is, so, so this peer is passwordless, but peer in ident, they are a bit different. So how they are different? So we will see how they are different. So peer connection means if OS user and TB user So if OS user and database user are having the same name with same spelling, not sounding same, but same exact same spelling. So then, admit without password. So that is peer connection. Okay. So, but this connection is local. Peer connection is only for unique socket or local. So it is not applicable to TCP connections. Ident. So, this is also same applicable to TCP connections. Host SSL. Okay. Connections. If OS user and DB user are same, then okay, admit without password. So these two connections are same type, peer and ident. The only difference is peer applicable only to the unique socket or local type connection. So whereas ident is applicable to host and host SSL connections. Host SSL, host no SSL connections. So this is applicable only to local connection. So that is the only difference between peer and ident, and both of them do the passwordless connections. Without password, they will admit the users. So without password, they will admit the users. Okay. So this is about our understanding about, our, so file about, how to write the rules. So how I can write these rules? Anybody? So rule number one is user's card should be able to connect TCP only to MyDB database. Okay. No other database from any client machine with Scramsha authentication method. So how can I convert this into the rule? Okay. So how can I convert this into the rule? Okay. So type, we have database second column. Third column is user. Fourth column is address. So fifth column is, method. So these are the five columns we have. Let us write some rules here. So I want to write the rule for the first thing. User's card should be able to connect TCP only. Okay. So TCP only connections for user's card. Okay. To MyDB database only, no other database from any client machine. So this is the rule I am right. This is the rule I need to translate that to the rule. So, so the connection is TCP only, that is host, right? Database What is the database here? User card should be able to connect to MyDB. So the database is MyDB and the user is start and address is okay from any client. So that means any machine. So we can say all here, all represent all machines. Method is Scramshaw authentication method. So Scramshaw authentication method. The rule number 2 here, the user's card should not be able to connect to other databases, right? So it should not be able to connect to other databases. So what I need to write is host all databases, user is card, address is any address. And here what I need to write? Any suggestion what I need to write here? So I need to
Reject.
write
Reject, I think.
So we don't want any connection from to other database from user's card. So always remember you have to write the first straight connection and reject connection should be written afterwards. If you write the reject connection first, so what happens is, the MyDB also qualifies as all databases, right? So all databases means it also includes MyDB. So if you write the reject rule first, so if the user is the Scott is connecting to MyDB, then in that case also that rule will satisfy. That rule will be what we say means it matches and it will reject. So the placement of the rules within the file is very important. In my case, if I have written this rule first, okay, just by mistake. So, this rule is there. So if I have written this rule first, what happens if I write this rule first and then MyDB rule second? Anybody guess what happens here?
It will reject all the database.
MyDB
It will
also
be
will be
reject.
rejected.
User start. It won't allow user start to connect, right? So, you have to connect to any one of the databases, but here, all databases. If the user is Scott is trying to connect to MyDB or any other, so it will reject. Okay. So it won't come till next rule. Once it matches the first rule, it won't go to the next rule. There it will stop reading the file. So it is like a ACL reading, in the ACL. So, so first rule is written, second rule is written, third rule is written, fourth rule is written. When a particular rule matches, so it won't read the rest of the rules. It won't go any forward. So it will stop there at the match. So here also it happens same. So it will stop at the first rule, and because the first rule is reject, so it won't accept, it won't allow the user's card to connect to any of the database. The point here is the placement of the rule is very important. So if you don't place the rules properly in the file, so you are going to end up with problems. Got it? So like this, and the second requirement is user Postgres should be able to make TCP, IP, or unique socket connection. So local. So here it is to any database, that is all, and user is Postgres. So and so with the password authentication. So, the user should, right now, locally, the user Postgres is not doing any, what we say, any password authentication. If it is password authentication, so usually the local type does not have address field. So it should be blank for local type. So because, it is a local connection, right? So, password means Scramshaw. So I'm writing one more rule for users Postgres. So any database, the user is Postgres, and address is, so okay, here what I had given is user Postgres should be able to make TCP or unique socket. Okay, TCP and unique socket connections to any database, but locally. Here I had given locally, but locally, right? So how you are going to interpret locally is, so it's a bit, locally means locally only. Okay, even TCP also locally. How you are going to interpret? So local TCP connection is something like this. See, so this is what interpreting locally. It is a TCP connection, that's a host connection, but from loopback IP address, that is the local IP address. So one is, unique socket, or, whether it is TCP IP locally. So in both cases, user Postgres has to produce what we say means password. Okay. So this is how you will be writing the rules. This is how you will be writing the rules in hba.conf file. Got it? So any questions here? So now let's understand what rules currently are there. So these are the 6 rules are there. What they are? So any user connect to, so unique socket connection for any database connecting, so any user. So if the OS user and the DB user is same, so so the connection should be accepted. Okay, in host connection, that is TCP, all databases, all users, when they are connecting locally. So here, we didn't open the connections for other computers. So still we are local here. So Scramshaw 256, that is password. Okay. So replication connections are different. So these are the replication connections used by both the standbys as well as backup tools. Backup tools also uses replication connections in Postgres. Okay. So the replication connections are also local, same peer, and replication. Okay, SAM's, these are all Scramshaw. So that is passwordless. So these are the rules we have. Probably what we need to do is these rules are more generic rules. They are not written specifically, right? They are written generally. So these are all generic rules. So what I want is, more specific rules here. I want more specific rules. Okay. So how can I write more specific rules for our users? All our users, Postgres. So we have Postgres, we have Sami user, Aaron user, and Scott user. So I will show you. So I will delete all these rules. I will delete all these rules. So all the rules are deleted. Okay. And I will write freshly. Okay. First of all, type. First of all, I am writing for my Postgres user. So rules for Postgres user. for Postgres. Okay. So what I want is, local any DB any DB. So peer host any DB any. So, I don't want this to be exposed. Client IP. So 127.0.0.1. Authentication scramshot. So for SCART user should be able to connect to MyDB only. Local or host. So MyDB. So password. Okay, for SAMI user, local or host. So MyDB and Postgres database with the password. And for Aaron user, okay, local MyDB, okay, password. Reject for other databases. Okay, this is what the rules I want to write for all these users. So how I am going to write, I will show and conclude this lesson. Okay. So for Postgres, any database peer and any database. So from localhost IP for a so first I am writing for Postgres. So local database is all, and the user is Postgres. Address is no local does not have the address. So it is peer connection. For same Postgres, I am writing I'm writing a TCP connection also. So when you give a specific IP, you also need to give the subnet 32. So, scram 256. And for my, the SCART user. SCART user should be able to connect to MyDB only. Sorry. Okay. Host. So what I have written for SCART user, local or host. So first let us write local. So my database is MyDB. So user is SCART. And address, we don't have address for local. So we give a connection peer. We can give a peer connection here because it is local. Or I can give Scramshaw also. Host start is allowed to connect to only MyDB. So here I am giving all. So any client, okay, any client machine. Scramshot 256. Okay, so that is about SCART, and I have SAMI user and Aaron user. So what we have for SAMI user, local R host mydb password. Local R host mydb, so only for mydb. MyDB and Postgres database. So SAMI user, and you have so no address for local, and it is also scram SHA 256 password needs to be submit given. So same host. So user is SAMI. So and here any client. So that is for SAMI user. So SAMI user has to give the password, whether it is a local connection or a remote connection. So in older versions, this comma separated thing does not work. So, so let us give one more for Aaron user. So for Aaron user, what is the requirement is local only, mydb password. So local for mydb Aaron, and so we don't have any address for local. So password. So these are the rules I have written. Okay. So one last rule I want to write: local, all databases, all users, reject. Host, all databases, all users, all host, all client machines, reject rule. So two reject rules also I have written. So that so if any one of these rule is not matching, so we don't want that connection. So if any one of the rule is not matching, we don't want this connection in this. So remember, so we don't have any connection for replication right now. So it will not allow any replication, or it won't allow any backup tools to run. Okay. So that is what, right now we have. So, but when we go to the backup lesson and replication, we will add rules for that. So this is what what we say means uh, file is. I will save this file. So you can see I have written these rules. I am expecting all these rules are good. So what I am going to do is, so I'm going to apply these rules, and also I am going to test. How to apply these rules? Once you make any changes to this file, so you need to reload the service. So then these rules are applied. So pg underscore ctl reload. So if you reload the service, the new rules are applied. So it will say only signal server send the signal, but it won't confirm whether these rules are accepted or rejected. So these rules are accepted or rejected, it will not tell you. Okay. So how you are going to do is, how you are going to verify is two methods. One is look into the log file. So look into the log file. So there is a error log file. If there are any errors in that hba.conf file, it will report in this log file. So go into the log directory, and you have this Monday file, right? So you have this Monday file. So let's check the Monday file. Tail monday.log. So configuration file contains errors. Parameter cannot be changed without restarting the server. So you have some. So SIGHUB is received. This is where we sent the, what we say means our. So this is where we sent our reload. So it says configuration file has errors. So what errors it has, it didn't report it, right? So only it tailed. So that means it didn't accepted our configuration file. So you simply say connect here. So there is a view in the Postgres. So it will tell us, so what rules are currently effective. If any rules have errors, so what errors it has. So that is select star from, so pg underscore hba file rules. So this is the view we have, and this will tell us any errors. It is not reporting any errors at all. It is not reporting any errors at all. So if there is an error message, it should report here in the last column. So it is not reporting any errors actually. Okay. So sometimes this is tricky because most of the time it reports the errors in this file. In this view, you will get the clear errors, but sometimes it won't give the clear errors. So one of the thing it is saying is, so configuration file contains errors, it is saying. In which line and all, it is not telling us. So what we'll do is we will restart the service, because it is also asking us to restart for max connections, so which is pending. So server started. So then I will do the same tail of Monday log. So database system is ready. So now it is not reporting any error. Okay, database system is shut down. So starting Postgres, listening on. So right now it has not reported any errors at all. So looks like everything is fine right now. Okay. So we can try it. So we can try, so logging in, and we can check the PG rules. This is the view we can check. Okay, always. Okay. So looks like we don't have any errors. So if there are any errors, the last column here. So if there are any errors, the last column here, okay, that shows the errors. Okay. So looks like we don't have any errors. So everything is accepted. So how can we check is So very simple, the user Aaron should try to connect to Postgres database, right? And user Sami should try to connect to template database and get rejected. So we can do this. The user Sami trying to connect to template one database. So user Sami is allowed to connect to MyDB and Postgres. Okay. So either local or host. So, I am trying to connect to template database. So that should be rejected. So what it is says is, okay, HBA.conf file reject connection for host for user Sami database template. So it says, this connection is rejected by HBA.conf file. Okay. This connection is rejected by HBA.conf file. So we will try to do a TCP connection and check. It's a TCP connection. Same thing, but TCP. Same thing here also. HBA dot connect reject for host. So earlier it was saying, HBA.conf file for host local. Right now, just to host and IP address it is giving, but still rejected. Whether it allows us to connect to Postgres database. Okay, yeah. So now, secret. So I'm able to connect to Postgres database. I'll be able to connect to MyDB also, right? MyDB also. So I'll be able to connect. So that is how the pghba.conf file controls, and this pghba.conf file is completely managed by DBS outside Postgres. So those rules are written from operating system. So those rules are written from operating system editor. Okay. So how this is completely outside Postgres, but when a connection request comes, hba.conf file is read and the rules are applied. So a copy of hba.conf file always retained in the memory, and you can view those rules which are loaded from, so the view pg underscore hba underscore rules rule. So this view pg underscore hb underscore files underscore rules. Any questions you guys have, you can ask. This is what the application security is about. Any questions?
Sami, in this configuration file, the last two line for reject, it is mandatory to put those two lines.
Not mandatory. Not mandatory.
Okay.
Okay, because because our rules are so specific, right?
Mm-hmm.
Why it's not mandatory is our rules are so specific to users.
Yes.
Okay, because we have written specific rules to user. We didn't use all at any for only for Postgres user, we have used all for database. For others, we are very specific about the user and database also. So that's the reason, chances of them getting, what we say means abused or getting so misused are almost negligible. We can avoid that reject rules. But if you are, sometimes we write the rules very generic also, right? So like all we used a lot. So in such case, it is so So reject rules also needed sometime, just I mean to say, give an example of, reject rules. But in my case here, it is not required.
So all these parameter, I mean, all this value of this column, na, if it is matched, then only it will allow to connect. If it is not matched, then it will not allow connect, right?
Yes. So it will match these four columns. These four columns it will match.
Huh.
So when these four columns are matched, that rule is taken.
Hmm.
Only four columns it will use to match. The last column is not involved in matching the rule. Got it?
Huh, got it.
So this is very important point. Okay, we should not think that the method is also part of matching. So it will not. So always, it is out of that matching. Only the four columns: type, database, user, okay, and address is matched. I will give one example. I will write a ineffective rule here. Same rule I am writing. So, here I am changing. So this rule is same as the previous rule. Only thing is, the authentication method is different here. Okay. So, but if you try to log in, so it will not ask for the password. Why? Because the first rule is matched already, right? The first rule is matched already. So the first rule is matched already. It won't come to the second rule. Okay. So, this only the match is done till here. So, the first rule is matched and it will never come to the second rule. So once the match is found, whatever authentication method is given, so that is applied. So the method does not participate in matching the rule. Only these four columns participate in matching the rule. So that's the reason. So this rule is useless here. It has no meaning at all, because this rule will never. So this rule is never going to be picked up. This rule will never match, because the preceding rule always matches. Okay. So that is the difference. So the method does not participate in matching. So, you have these four columns only, which are part of matching the rules. Hope everybody got this point. Any other questions? Okay, that is about our, so Postgres, this thing. So we have one rule here. I want to show something. So we have one rule here. So that rule is, so local rule for SAMI user and local rule for SCART user. So particularly SCART user. So if the local connection, if the SCART user is doing the local connection, so it should be the peer connection. Peer connection means OS user and the DP user, if both of them are same, so that is peer connection, and it is a passwordless connection. Okay. So we have a local connection for SAMI user also, but that requires a password. So let us try. We have tried for SAMI user, right, already. So we have tried for SAMI user. So we did a local connection also for SAMI user. So now I am doing for Postgres database, I am doing a unique socket connection here. So it asks for the password, and if I give the password, the connection will be good enough. So, but for the SCART, I want a peer connection. For SCART user, so peer connection means we should have a OS user also whose name is SCART. So I am exiting from here. Oops. Oh, I need to reconnect. One 172.23 dot 24.172. Change settings and appearance change. So bold and 18 font. So okay, and come to the session. So I'm giving my lab, save, apply. So that is going to be I use small window because in the Teams and also bottom part of the screen is not clearly visible, presenter screen. So that's the reason I'm using small window. So I'm connecting as admin. So password also admin. I will create a new user named as OS user, Linux user SCART I am creating. So cat etc password. So this is the file where Linux saves all its user details. So right now we don't have any SCART user. I am going to create a SCART user. Sudo so user add SCART. So password, sorry, sudo password SCART. So password also add given. I have created a operating system user SCART. So I will now change to SCART user. Okay. So who am I? I am SCART user. So if I say PSQL, okay, port is 5433. So database is, let us say, so MyDB. So it should connect without asking the password. So it is connected without asking the password. On info. So it is via socket connection, peer connection it is doing without password. So here, the DB user is also SCART and the OS user is also SCART. You can see the DB user is SCART and OS user is SCART. So that is the reason the peer connection has happened. Okay. So the peer connection has happened. Okay. Without any password. Got it. So that's about it. So that's about this lesson. So any questions you have, you can ask right now. So we are going to conclude this lesson. Actually, we have concluded this lesson. So I'm taking that as everybody is clear and no questions at all. So now what I'm going to do is I'm going to we have another, so 12, 13 minutes for our break. So we are going to discuss a very quick topic that is SSL connections. Okay. So you guys might be aware of SSL, right? So you guys might be aware of SSL. I am sure everybody is aware of. Correct? If anybody not, so they can ask. There's nothing to shy about. Not knowing is, nothing to shy about. So the SSL is now called as TLS. SSL is not now called as TLS. So it is same SSL, so or TLS, whatever you call. Many people still call SSL only to TLS. Many people, confuses that SSL is different and TLS is different. But TLS is next generation SSL. So it is the successor or the next generation SSL. TLS is transport layer security. So both of them applies to TCP IP connections. Both of them applies to TCP IP connections, SSL, TLS. So we should now it is TLS, transport layer security. So earlier we used to call it as SSL, secure socket layer. So now it has a more meaningful name. So it is a transport layer security. Because TCP IP is a transportation of data from client to server, right? So while you are transporting the data between client and server, so we should make sure that the data does not fall in the wrong hands. So who can then read that data and steal the information? So how we are going to ensure is, so before sending the data, we are going to encrypt the data with a key and then send it to the server, and the server can decrypt it and read it. And when the server sends the data, it also encrypts it, and it will then send the encrypted data to the client. The client decrypts the data, then it will be able to read it. So in the middle, if anybody grabs that data, when you are transporting, there could be some thieves, right? They can grab. Let us say you are sending some goods from one city to another city. So you hire one truck and you put all your goods in that truck and you are sending that. So the thing is, that goods should reach the destination address properly. Okay, so definitely they will reach, but sometimes some thieves or bulgars or dacoits will be there in the middle of the road. They will catch it. They will catch it. So that is where we have to protect our data. So if you are if your truck is properly secured, so it is completely with state of art locks and all. If it is secured, so the bulgars or dacoits may be able to intercept, but they will not be able to open that lock because it is a high security lock, and they will not be able to steal anything, right? That is what transport layer security ensures. So even if somebody steals the data, make a copies of the data which is in the TCP network, so they will not be able to make any sense out of it. They will not be able to read it because it is completely encrypted. Only the concerned server and the client can decrypt and read it. So that is how the data transport between client and server over the TCP network is secured. So TLS and SSL are applicable only for TCP connections. They are not applicable to unique socket connections. Okay, not in just in Postgres, but anywhere. So whether it is any database, so they are not applicable to unique socket connections. They are only SSL is used only for TCP connections. So that is secure transport layer. So that is secure socket layer or transport layer security. So now, because of the sensitivity of the data and the awareness about the many people want to protect their data from hacking and all, so it is becoming mandatory for implement TLS. Okay, TLS implementation is very very simple in Postgres. Postgres supports both commercial certificates and self-signed certificates. Self-signed certificates. So what we do is we will create a self-signed certificate on Postgres server. So we will call that self-signed certificate as root. Okay, certificate authority. So usually, in TLS, we have two things. One is we have three things actually. You have the certificate authority or CA. So the CA will give the certificates both to the server and client. So the client, for client and server, the CA is common. Okay, certificate authority is common for both server and client. So it will validate the the keys and all CA certificate. It is actually a certificate or a file. So basically it is a file. So generally, the CA, okay, CA in self-signed, the server acts as CA as well as server and also, sometimes maybe as client. But in general, what happens in commercial certificates, so, the CA is Verizon, etc. Okay, other vendors, Verizon, other vendors. So, they will provide a public key. So this guy CA will provide a public key and a private key. So public key is given to client and private key is retained by server. So public key and private. So generally, if you are purchasing the commercial certificates, you will have this. Okay, you will have the third party CA. So third party CA means Verizon. I think AWS is also right now providing it is providing the CA certificates. So along with the CA, they will also provide key, private key and public key certificate. These are the files they will provide. Okay, so you have to purchase money and purchase those files and everything. So generally they will verify. So they will verify. On other hand, you can also generate self-signed certificates. Okay, here Postgres server will act as CA. Certificate authority. Okay, so you have to create a CA certificate here. A root certificate. So you need a CA root certificate. You need a public server certificate. And you need, okay, so what we say means a key to the server. So these are the things you need. So server certificate and key and CA certificate. So the Postgres server itself act as certificates, and there are open SSL commands you can use to generate these. So you can use open SSL. every Linux system will come with OpenSSL, and on Windows systems, you need to install OpenSSL. Okay. So OpenSSL comes with every Linux system. So you can use OpenSSL. So you generate a CA certificate, you generate the server certificate, you generate the server key, and you also generate the client certificates here. The client also needs a client certificate and client key. So two files. So for that, all these are, the files. So which you need to generate using OpenSSL. So there is a OpenSSL command in Linux. OpenSSL command. So that command is always complicated. Not complicated, but you can never means it is difficult to remember that command. So OpenSSL commands, always keep a note of it and keep that note ready. So because OpenSSL commands are very long and they are a bit confusing, so it is hard to remember. Some people are good at remembering it, but there are only few of them who can remember those commands. So if you can't remember a OpenSSL command, so just forget it. It is very normal. So that not to remember the OpenSSL command given its lengthiness and its complexity. Okay. So what you need to do is you need to, okay, make a note of those commands, and whenever needed, just use that notes. Using OpenSSL commands, you can generate all these certificates. So what we will do is, I will just take 2 more minutes, 5 more minutes, and before going to the break. So and then we will go to the break. So after coming from the break, we will do one more lesson, table spaces, and we will stop for today. So we'll go to the lab. So where you will do this, the security, we will do the OpenSSL thing, and you will do the table spaces. So, okay. Okay, there is a file called as OpenSSL. I had given the notes how to generate OpenSSL. So you need to create the server root certificates, server certificates, everything. So first of all, you have this OpenSSL command where you are generating CA certificate. So CA cert PEM, so you are generating CA certificate. So, and then you are generating what we say means server certificate. Okay. So this is server certificate and server key, and this is CA certificate. Okay. So after using that same CA certificate, you will also be generating the client certificates. So which you can copy over to the client. Client also will have client key PEM and a client. So what we says, so certificate PEM. So you will have a certificate and key. Two things you will have. Okay. So this CA certificate is, it remains common for both client and server. So these are the certificates you are generating. So I had given you the commands how to generate these certificates. So and steps. So we will do a lab exercise for that. Okay. And then in our PostgreSQL.conf file, we will enable SSL, and then we will configure this certificate things. And we also need to write a HBA conf rule also. So otherwise, SSL is not allowed. Okay. So this is what we do. Okay. So after we come back, after we come back from the break, So we will take a, so we will complete table spaces lesson, then we will go to the lab. So we have 3 lab assignments today. One is, the HBagon file. Second one is SSL. Third one is, the table spaces. 3 lab sessions we will do. Okay. So, yeah, we can go for the break. So right now it is 4:15 p.m. So we'll take a 15 minutes break. So we will come back at 4:30. Right? Okay, guys. Oops. I have given 4:30 as the break time. Actually, I meant only 4:20. So because we started 5 minutes late, right? So I thought 4:20. By mistake, I think I put 4:30 here. Anyways, okay, 10 minutes does not going is not going to spoil anything. So let's wait for others to join. So we have one more topic to go and then lab, so no issues. The table space topic is not a very big topic. So we'll wait for 4:30. In the meantime, if anybody has any questions, so they can ask. So anything from the lab exercises you guys are able to do, complete it on time or not, you can ask. Table spaces. Okay. So let's get started. So just we'll wait for 2 more minutes and then we will start. So by mistake, I declared 4:30. Actually, I meant 4:20 only, 15 minutes break. So by mistake, I did 4:30 announcement. So that's the reason we have to stick to that. Okay, guys. So let's start. Our next topic is table spaces. So for those who are familiar with the Oracle database, you are quite familiar with the table spaces, right? So, and for those who are familiar with SQL Server database, you have file group in SQL Server. So, which is actually the table space. Which is actually table space of Oracle, or the name is different, but both are same. So, table space or file group in Oracle database and SQL Server database. I am not sure what it is called in DB2 database. So I am not sure of that. Okay. So anyways, the table spaces concept is same here as well. So in Postgres also, the table space concept is same. Okay. So it is also, a logical object, logical storage unit table space. So when you create table or database, you can, or index, you can mention, so this table is going to be in so and so table space. So this database is going to be in so and so table space. So you can mention, so the table space for that database or that table or that index which you are creating. Okay. So the by that, you can, the main use of the table space is managing the disk space. So you can put some files on, one file system, another files, some more files on a different file systems. You can scatter your files across the system and you can take advantage of all the hard disks which are attached to the system. So otherwise, you are confined to just one location on the file system, right? So without table spaces. So that is the main idea behind having the table spaces or file groups. So that is, to make effective use of the storage. to scatter the database files around the storage. That is the main objective of table spaces. The difference between Oracle tablespace or file group of SQL Server and the Postgres tablespace is, so Postgres tablespace points to a physical directory, one single physical directory. So whereas the Oracle tablespace or file group in SQL Server points to, okay, data files, right? They point to the data files. Those data files may be created on different, so directories. So that is the major difference between the table space of the Postgres and the table space of Oracle. Oracle table space points to data files and Postgres table space points to a directory on the file system. The reason for this is, the storage of Postgres. In the configuration, in the architecture lesson on first day, second day, we learned that. So, the Postgres, okay, tables and indexes does not share the files. Every table and index have their own file. So that's the reason Oracle style table spaces or SQL Server side file groups are not possible or not viable in Postgres. So because there the tables share the files. You may have one or two databases. 100 tables are sharing those two physical files. Here, if you have 100 files or 100 tables, all 100 tables will have 100 files of their own. They don't share. So that's the reason, a directory is more suitable here. So all 100 tables you can put in that table space, right? So which uses this particular table says all 100 files you can put in that table space subdirectory. So that is the idea behind having the table space. So which is pointing to a directory here. Any questions here? So there are two predefined table spaces which actually discussed earlier. So one is PG global and other one is PG default. So these are the predefined. When you install Postgres, so both of them are created in the data directory, or what we say means, the cluster data directory. So, both the table spaces are created in cluster data directory. Later on, you can create additional table spaces in other file systems. Okay. So in other file systems, you can create additional table spaces. In our lab right now, we have only one PG default table space. So we can add more and more table spaces as we need. So before adding a new table space, always you need to have a directory, because table space is pointing to a directory. Always you need to have a directory. Okay. So always you need to have a directory there. So first create the directory, then create the table space. The table spaces are owned by a particular user. Okay, the table spaces are owned by a particular user. Any user want to create any table or any database in that table space requires a create privilege. So you can see the privileges belonging to our table space. So you go to that lesson, user lesson. So in this user lesson, we have this table. So, which will tell. So what privileges are applicable to the table space? The only one privilege is applicable. So that is C. So that is create privilege. So create privilege is applicable. Okay. On table space, no other privileges are needed on table space. Okay. Create privilege is needed if the user wants to create a new what we say table or index on that or database on that particular table space. So the user requires create privilege. So before you create a new table space, so to create a table space, you need to be a super user. Only super user can create a table space. So normal users will not be able to, and you need to so create a directory first and then create the table space. Okay. So let us go and check what table spaces right now we have. Okay. So I'm going to the lab, and in the lab, so I will connect to Postgres. So I'm connecting to the Postgres user. So here I'm saying PSQL. So P5433. So I'm connected. So I'm running the command db command. So I have two table spaces already. PG global, we discussed earlier, it is a system table space containing global objects. The global objects are table space, user, and database. These are the three global objects plus. So these are the three global objects we have. Okay. So all global objects are, will be there in the PG global table space, and PG default is for all databases. So user tables and, local data dictionary objects. So the PG default is used. These are the two table spaces by default configured. So let us, how to create a new table space is very simple. First, you require a directory for the table space. And that directory must be owned by Postgres service user. So Postgres service user. Okay. So like this, the 14 and data directory are owned by Postgres service users. With these permissions, read, write, and execute only for the owner. Okay. So others does not have, the group does not have any permissions, and others also does not have any permissions here. So the permissions should be very, very strict. Okay. So I am creating a new directory here. So to be used as the table space, mkdir my tbs. So I'm using the table space name as my table space, or you can give any table space name you want. So you can say this is what the Postgres and Postgres. This is what So you need to have the crisp permission, but this has extra permissions. The group users have read and execute permission, and others also have read and execute permissions. We don't want this. We want the owner Postgres to have read, write, and execute, others none. So what I can do is I can use the command chmod. So 700. So my TBS I am giving. So now you can see the permissions have changed. So the permission should be stricter for the table space directory. Okay. So once you create the permissions, right? Once you set the permissions, you need to log in to the PSQL, and you can create the table space. So the command for creating the table space is very simple. Create table space name. You can set the owner of the table space and location within the single quotes, the directory. You have to give the full path, don't give the relative path. So I'm saying create table space, my TS. So my TS, okay. So location, because right now I am logged in as Postgres user. So, I am avoiding that owner class. If you avoid the owner class, automatically the current user will become the owner of the table space. So location is where live, okay, PGSQL. So my TBS, this is the directory I have created, right? So my TBS directory I have created. This is the SQL command I am using. You can also run this command from PG admin as well. So it works from PG admin also. Spelling mistake. Table space. So the table space got created. So table space got created. And you can see that from this command db. So my TS is the table space name, Postgres is the owner of the table space, and the location is where live PG SQL my TBS. Okay, any questions here? So creating a table space is not at all a issue, not at all any problem. It is quite simple. First, make sure you have the directory with proper ownership and permission. And once you have that, you just run the command create table space. There is a data dictionary object associated with the table space. So PG underscore table space. So it is a table, it is not a view, a table where table space information is written. So it has these columns OID. Every object will have OID. Table space also have a OID. SPC name means table space name. SPC owner, SPC ACLs and options. So there are certain options you can set. So we will discuss that options are later on. So this is what we have here is select star. So I will just say expanded display on select star from. So PG underscore table spaces. So what I will do is simply, I will copy paste these things. So yeah, okay, our my TS table space is there. Even without expanded display also, it should have been good enough. Okay, do you see any problem here? Okay, do you see something odd here in this? This is the table. It should contain all the details related to table space. So this is my table space and the OID of the table space is 16405. Name is my TS, owner is 10. 10 is the OID of Postgres user. So we didn't assign any granted any create permission to anybody. So if you have done so, it will come here and we didn't set any specific options. So do you find anything odd about this output? Anything odd? Anything which which you don't like or which you have questions or doubts about?
I think that the DBs are being restricted to use this table space
No, where it is written.
because it is not been granted. Believe so.
It is granted only for users to create tables. DBs don't own any permissions. We don't grant any permissions to DBs.
Oh, normally, how can we restrict to use this table space from the other DBs?
DBs, any DB can use the table space. You cannot restrict.
Exactly, but in case if we want to restrict that other DBs to be not to be used by this table space, can that be done?
It is rather the question is, the DBs cannot control that. Only user can control that, right?
Okay, okay. So table space we cannot restrict. Only user
You
level
cannot
only we can
restrict.
restrict.
Yes.
Okay,
Table space,
okay.
you cannot restrict any DB. If the user has the create permission on that table space, so, the user can create objects in that. So, generally, so if you want to use a table space for a database, right, I think you are trying to do something like this. We have a employees database. I want to have one table space, which should be used only by employees database, right?
Exactly, exactly.
So you need to have that written rule so that no other database should use this table space, and you have to restrict the DBS from doing that. DBS will be able to do it, right? Other
Okay.
users cannot do it. So you should tell the DBS that don't use this table space except for employees database.
Okay, so we have to do it at a user level only. We cannot
Yes,
be done
user
at
level.
anything at a table space.
Yeah, but DBS can do everything because they have access to super user. Normal users will not be able to use it.
Okay, in case if we have a super user, then can that be done?
You super user have no restrictions, right? Can do anything, right? So you cannot restrict super user. So only oral communication, oral, what we say means direction you can give to the DBS that don't use this, okay, table space other than this database. So that should be an oral directive to the DBS. Okay. So within the database, you cannot do anything. Within using any of the commands, you cannot do anything to restrict. So every database can use every table space available. So
Okay,
some
okay,
you can put in one data table space, some tables you can put in another table space. So
okay,
each
okay,
database can use all available table spaces.
okay. Got it. Thank you.
Okay.
Sami, so when we create database, on that time we pass table space name, right?
Yes.
So does it means that database use that table space? I mean, does not.
Yes. 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 But that is not restricted. Okay. Some tables from that database can also use other table spaces. Okay. Got it. So when you create a database, usually you can assign a table space to that database. In normal circumstances, all tables uses that. But some tables, you can still make them use other table spaces. As I said, each database can use all table spaces available.
Okay.
Each database can put its table in all table spaces. Okay.
Okay. Does it means that if we create any database and if we are using that table space, my TS, so after that, if we create any table under that database, so by default it will create under my TS. If
My TS
ex-
only.
explicitly, if we want to change, we want to create any table under any table space that we can do.
You
But
can
by
do. So
default,
you have the create tables, right? Create table statement or alter table statement. So they have the table space option. Okay. So, create an alter table, have table space option. So
okay,
that
here we
table
can
will be
pass the table.
created in so and so table space. If you don't mention it, they will be created in the table space of the database.
Got it, got it.
Okay, so my question was this one. So you can see this output, right? So PG table space is the main object where details about the table spaces are saved. But you can see here, so nowhere it saves the location of the table space, right? Where is the location of the table space? Okay, it is not saved anywhere in any database, any of the system table. So the location of the table space is managed outside the Postgres. Okay, so DB command is giving you the location, but actually the table space PG underscore table space table, which is supposed to contain the details of all the details of the table spaces, lacks that. Okay, so because that information is not saved in the data Postgres, it is saved outside Postgres. So where it is saved is, so before that, you may note of, OID of the MyTS, that is 16405. So go to the data directory, and in data directory, so there is a directory called as table spaces, PG underscore table spaces. So PG underscore table spaces. So we'll have this. Okay. So the OID is 16405, 16405, 4005, and so the location is where like PGSQL my TBS. So the location is always you can find from this particular. So from this particular, what we say means directory within the data directory. Okay, and you can see it is a soft link here, right? So it's a soft link, which is pointing to the directory which we have created for the table space. Okay. So, that gives you a lot flexibility. The only thing is, the main table of table spaces does not contain any, so does not contain any reference to the location. So apart from that is, if you leave that particular, if you leave that out, so it gives you more flexibility. So you can always change the location of the table space. You can, if you want my TBS directory to be located somewhere else, so just to move that directory and update this symbolic link. There is no need to do anything within the database. So within the database, there is no need to do anything. So just, you need to move that directory to some other place and update the symbolic link. Drop this symbolic, delete this symbolic link and recreate the symbolic link with the new location. Always you can do that. So, the table space maintenance, like moving the table space from location to another location, so does not require any action from the database. Within the database, no queries are required. Simply from operating system, you can move this out and you can recreate this symbolic link and it will work perfectly. Hope everybody understood the importance of this symbolic link, right?
So does it offline activity? I mean, do we need to stop
There
database
is
and
no
then?
need to stop and start. Even while the database is, while the Postgres is running, you can do it. For this, to change the table space, there is no need for you to do any kind of stop and start activity. However, so if that there is a lot of data, moving the data takes some time, right?
Yes.
Obviously, it will take some time. So if you are moving this directory to some other location, some other mount point, so what happens is, that will take some time if you have a lot of data in it, right?
Yes. Correct.
So that is going to be, so during that time, so, the tables or databases which are part of that table space will not be available. Okay, they would be available. So, but other tables, other databases will work normally. So, that is also a, so that is also a good thing. So it does not moving this directory does not require any, so any start and stop service. Okay.
Okay, I
Hope
have one
you
question.
understood. Sure.
So for example, if you do some update in some table, which is part under this table space, okay? So it is middle of that time, if I move, then what happen on that query? Is it fail or?
So that query will fail.
Okay.
That query will fail. Okay. So if you somebody started, moving that table space out, that query will fail. And other thing is, so other thing is, so if somebody has ran that query after you started moving, so in that case what happens is, the query will fail in the beginning itself. So it is best to, you can do it online, but it is best to, make sure the users don't do any operations on those tables. Okay. So users
Yes.
don't do any operations on those tables while you are performing the main. It is a maintenance activity. So ideally it should be done in maintenance time only. So, but it does not require any downtime. So there is no need to start and stop the service. That's the point.
That I'm asking. I mean, downtime is required. I mean, in real environment, we should inform to that team.
Yeah,
That
you
means,
should inform others,
that
you
means
should
it is
inform others. Or you should make sure, those databases and users are not access. You can write rules in hba.conf file. Usually, application uses that tables, right? Normally, DBS don't use the application tables. Application user uses it, right?
yes, correct,
So you
correct.
can restrict that application, or you can restrict that application, or database also has an option to disallow the connections. So you can alter the database. So alter database. Okay, options are allow connections is option is there, right? So you can set it to false. So let us say, one table space is used by some tables of a database, or, some a database. So what you can do is you can allow for the during that part, you can disallow the connection to that database. So that makes others not to use that database. So that makes so then you can perform your operation, or you can inform the user stop the application and do anyhow. So you must avoid any kind of operation. If the user tries to do any kind of operation during your moving, so they will get errors, and also you have to do it definitely during the downtime only. So it does not require a restart. Okay, that is about it. Any other questions? So if a database is in one table space, you can also change it with this alter database name, set table space, a different table space name. You can change the table space of a database, and also it is possible to change the table space also. Okay, you can say alter, so table, okay, all table space in table space name, okay, set table space to new table space. So you can also change the table space of a particular table. You can also change the table space of a particular database at any point of time. So there is no need to worry about, so it also moves the files. So if you alter a table, so to a different table space, it will not just alter, but also physically it will move the data file to the new table space as well, automatically. So only alter table command you need to give, or alter database command you need to give. The required files, data files will be moved by, so the required data files are moved by the Postgres itself. Hope you got the concept right. So let me quit here, and so I will go to my TBS right now. So it has one directory here, so which is telling the version. It is empty right now. This directory is empty. So what I'm going to do is I'm going to connect to Postgres database, and I'm going to create one table in Postgres database which uses this myTS table space. So I will connect to Postgres database, and then I will create one new database which uses this table space. Okay, so first I'm going to create one data. Already we have two tables here. So what I'm going to do is create table test TBS. Okay, ID integer. So table space is my TS. So I have created this my test TBS table in my TS data table space. So we have this. Okay, so test TBS is there. So what happened in the background? So let us check. What had happened in the background? Let us check. Okay. So before going that, I want to query our PG class. OID comma rel name. So comma rel file node. So from PG underscore class where rel underscore name is equal to, so test underscore TBS. So the OID is this one, and the rel name is this one. So rel file node is this one. So the data file of this test TBS will be, the data file name of test TBS will be this one. So exit from here, and you go here. So right now we have a subdirectory. So that subdirectory is the OID of our Postgres directory. You can check out. So CD13. So PWD, so you have here, and you do one thing here, LL. So you have one data file of 0 kilobytes. So 16406 is our rel file node of our test TBS. So that data file got created here. Okay. So and Postgres database also got a subdirectory here. So this is the OID of Postgres database. Okay, now I will log in back and I will create a new database which uses this table space. Create database. Okay, so I am saying test DB. So test DB. Table space is my TS. So database is created. Before going here, I want to know the OID of new database. So OID comma dat name from, so PG underscore database. Okay. So where dat underscore name is equal to, so what we have is, test DB. So you can see the OID of, that database is 16409. Now exit from here. Okay. So right now I am in this. Okay. So check out. So you have two directories here. One is 1649, which is nothing but the OID of newly created test DB. So this is what, this is what happens. So when you create a database and when you create a table in that table space. Oops. Any questions here? Okay. Okay. So, so that's about our table spaces. If you have any questions, you can ask. So you can alter the table space. Okay. Not yet finished. So there is a parameter called as default table space. So default table space is empty. That means, it is the database table space or, the PG default. So if the default space table space, if you set any table space, then all the tables you create, so they go into that table space only. All the indexes, databases, which are all the index database or tables, whichever you create, so they will go into the default space, table space. Right now it is not set. Okay, you can also set that. So there is a temp table space also, temporary table space. So this temporary table space is used by Postgres for, the for the creating the temporary tables and temporary files. So sometimes, if the work memory is not sufficient, Postgres requires to, sort on the disk. So it needs to create temporary files. Where those temporary files should be created, so you can specify the location using temp table space. Okay. So that is what the temp table space, I think that is also not set now. So right now it uses the default table space. So is the default. So temp underscore table space says. So you can give more than one table space for temporary. So you can give a list, comma separated list. So temporary table spaces. That's the reason it is not space, it is spaces. So you can give more than one table space as temporary table space. Okay. So, so you can alter the table space and you can do two things. You can rename the table space any point of time. If you want to change the name of the table space, so you can rename. So you can also change the owner of the table space at any point of time. So you can drop the table space, but it won't drop if there are any tables or any databases using it. So you have to move the objects out of that table space before dropping that table space. So if you want to drop the table space, you have to move the objects out of it. So basically tables, indexes, and databases uses the table space. So you need to move the objects out of that, okay, table space to different table space, then you can drop it. First empty it, then drop it. So that is about, our table spaces. PG underscore table space stores the information, but the location information is saved on the subdirectory called as PG underscore table space in cluster data directory. Okay. So that is about our table spaces. If you have any questions, you can ask me right now. Otherwise, we can go to the lab. We have another, so what we say means 48 minutes. So we can go to the lab for that 48 minutes. So we have 3 lab exercises to do. So already, so I kept those lab exercises. So, security, SSL, and table spaces. Security, SSL, and table spaces, 3 of lab exercises we have. I think they are already uploaded. Let me check. Yeah. So security, SSL, and table spaces. So not much actually, 40 minutes should be enough. So for this, so we have 8 more minutes actually. So, but we will go to the lab now. So today's lab, we will finish today itself. So that's about today's class. So if you have any questions on any topic, you can ask. So otherwise, you can just go to the lab and you can finish the lab exercises.
Swami, I have one question that if by mistake, if we delete that directory, table space directory,
You recreate it.
okay.
And recreate it with proper symbolic link that works.
Recreate means can we restore from file level and file system level and recreate, I mean, create that link? Is it work?
You can do that one also, or you can use mkdir command, and you can also use ln command, so both these commands you can use. So these 3 files you need to do. So 6, 5, and 4. Okay. So we have another 45 minutes. I think we should be good in these 45 minutes. So we should be able to, so they are not very big tasks like we have in database.txt. So database.txt is a very big assignment, but rest of the assignments will be very smaller ones. Okay. So I will be at desk. but muted. So, you expect some delay in response because I have to unmute and respond to you. You guys, I'm at desk, so if you ask any questions, so you can ask. So probably I should also stop recording because we are now not learning anything new. So I will stop recording unnecessarily. The file size will be huge. So it's okay to stop recording, right? Okay. So I have stopped recording.